DSPy employs modular composition to implement retrieval-augmented generation pipelines, where chain-of-thought reasoning is applied to contextualized question-answering tasks. The framework's optimization mechanism, MIPROV2, will be shown configuring few-shot demonstrations and refining natural language instructions through Bayesian search over the program's prompt space. The upcoming code snippet demonstrates how a RAG module is initialized with a chain-of-thought responder, while MIPROV2 compiles the system by generating optimized instructions and selecting high-quality demonstrations from both labeled and bootstrapped examples.
Class array DSPy module. Definite self, numdocs equals 5. Self numdocs equals numdocs. Self respond equals DSPy. Chain of thought context, question response. Def forward self, question. Context equals search question, K equals self. Numdocs hash not defined in this snippet, see link above. Return self. Respond context equals context, question equals question. TP equals DSPy. MIPROV2 metric equals DSPy. Semantic F1, auto equals medium. Num threads equals 24. Optimize drag equals TP. Compile RAG. Train set equals train set. Max bootstrap demos equals 2. Max labeled demos equals 2.
This code demonstrates a retrieval-augmented generation RAG system using DSPy's chain-of-thought module, optimized with the MIPROV2 optimizer. The RAG class encapsulates a simple pipeline where retrieved documents are passed to a chain-of-thought reasoning module to generate responses. The forward method retrieves context using an external search function, then delegates response generation to the chain-of-thought module with the signature, context, question response. The optimization process uses MIPROV2 with semantic F1 as the evaluation metric, configured for medium-scale optimization with 24 threads. The optimizer compiles the RAG system using a training set, generating up to 2 bootstrap demonstrations and 2 labeled demonstrations. This approach leverages MIPROV2 ability to simultaneously optimize both instructions and few-shot examples, making it suitable for tasks where both prompt structure and example selection impact performance. The design choice of using chain-of-thought suggests the task benefits from intermediate reasoning steps, while the MIPROV2 optimizer is particularly effective when you have sufficient data 200+ examples and can afford longer optimization runs. The aught equals medium setting balances optimization quality with computational cost, making it practical for production scenarios where you need improved performance without excessive resource consumption. Let's break it down.
Class array DSPy module.
Defines a class named RAG that inherits from DSPy module, establishing it as a custom DSPy module for building language model programs. This creates a foundation for implementing retrieval-augmented generation functionality within the DSPy framework.
Definite self, numdocs equals 5. Self numdocs equals numdocs.
Initializes an instance variable numdocs with a default value of 5, storing the parameter passed to the constructor. This sets the maximum number of documents the class will handle unless overridden during instantiation.
Self respond equals DSPy. Chain of thought context, question response.
Creates a chain-of-thought module named respond that takes context and question as inputs and generates a response as output. This module is designed to handle reasoning tasks by breaking them down into intermediate steps before producing the final answer.
Def forward self, question.
Defines a method named forward that takes self and question as parameters, serving as the entry point for processing a question input in a DSPy module. The method is likely part of a class-based signature where question is the input field to be processed by the module's underlying language model.
Context equals search question. K equals self. Numdocs hash not defined in the snippet. See link above.
Calls the search function with the question as input and K parameter set to self-numdocs, storing the result in the context variable. The function retrieves relevant documents based on the question, with the number of documents controlled by numdocs.
Return self. Respond context equals context. Question equals question.
Calls the respond method on the current object instance, passing the provided context and question as keyword arguments. This triggers the module's response generation using the specified context and question inputs.
TP equals DSPy. Miprov to metric equals DSPy. Semantic F1, auto equals medium. Num threads equals 24.
Creates a miprov2 optimizer instance configured with semantic F1 as the evaluation metric, medium-level automatic optimization, and 24 parallel threads for execution. The optimizer will generate and refine instructions and few-shot examples using Bayesian optimization to improve program performance.
Optimize drag equals TP. Compile RAG. Trainset equals trainset. Max bootstrap demos equals 2. Max labeled demos equals 2.
Compiles a RAG retrieval-augmented generation module using the TP compile method with a specified training set. The compilation process is configured to use a maximum of 2 bootstrap demonstrations and 2 labeled demonstrations from the training set. This optimizes the RAG module by generating and validating examples to improve its performance. This implementation showcases DSPy's modular approach to building RAG pipelines, where the RAG class encapsulates retrieval and reasoning in a clean, composable structure. The ChainOfThought module handles the reasoning step, breaking down the task into intermediate steps for better accuracy, while the external search function provides the retrieved context. The real power comes from miprov2 optimization, which simultaneously refines both the natural language instructions and the few-shot demonstrations. By configuring it with semantic F1 as the metric and balancing labeled with bootstrapped examples, the system achieves robust performance without excessive resource consumption. The auto equals medium setting strikes a practical balance between optimization quality and computational cost, making this pattern particularly effective for production scenarios where you have sufficient data and need reliable, interpretable reasoning. The design choice of using chain-of-thought reasoning suggests the task benefits from structured intermediate steps, while miprov2 Bayesian search efficiently explores the prompt space to find optimal configurations.
The RAG module fetches shadows from silence, while ChainOfThought weaves them into truths that dissolve upon reading.